Article 352, PVC. This is a huge wiring system. And Victor, I need to ask you and Eric the same thing. I remember when I was working in the field, PVC was relatively new. And it was a problem. People did not want PVC in industrial or many applications to be installed above the ground. They didn't even want even PVC at all. Have we moved in the last 30 years that or is the engineering community still resistant to PVC in many applications? Or do you guys, no, and whenever we can, we're putting PVC. What's the attitude there? Victor?
I think we're still kind of restricted on it. We're still looking back at it as not being the best thing to have above ground, particularly if, inside the buildings, you don't want, we really restrict it, but even outdoors above ground. Sometimes we'll do Schedule 80 and do that, but.
Okay.
Yeah, I see it a couple different locations. Underground, okay, but typically what they'll do is only for the straight runs underground. When you get to the elbows and to the stub ups above ground, that's always going to be metal. The other thing we'll use them for is to surround grounding conductors. So if we're running a grounding or bonding conductor from one piece of equipment to another, if it's on a wall, we'll put it in PVC. The only other place I see it is, for example, if we have some battery conductors, one polarity, we'll run it in either aluminum or PVC.
Okay. Brian?
I'm just going to say here in Florida, from an electrician standpoint, we do not like running metal conduit anywhere that we can avoid it. So we use PVC. Schedule 80 a lot, but PVC everywhere we can, just because of corrosion.
Okay. Ryan, anything?
Yeah, I love it. I don't know anybody that's ever gotten shocked on PVC, so the more the merrier, in my opinion. But there's some utilities that still get freaked out, and they want steel raceways for the utility conductors. Well, not so much for the masts, because that, strength issues.
No, I mean the down.
Yeah, for the lateral or underground service conductors.
They want to see metal.
They want steel.
Yeah, so we still have a little of that, Yeah. All right, so let's move on. Here's the graphic. Now you have Schedule 80, which has a thicker wall thickness. We probably should have these both look in the same thing, which is a little thinner. Okay. And Schedule 40. Now, the UL White Book, you want to read to me, Ryan, when you get a chance? I'll come back to later on about Schedule 80 versus Schedule 40. We'll talk about that on physical damage.
Sure.
All right, and then we'll move on. 352.10 uses the PVC. It can use in almost every application, obviously where it's not sub-physical damage. But in extreme cold, PVC conduit can become brittle and is more susceptible to physical damage. So I'm sure guys that are up in Rocky, they used to be working in Alaska, and other guys up in the north somewhere where it's very cold, when it gets cold, it doesn't take much to damage that wiring system. So there's an informational note because the code can't tell you when you can't use it, like that case. PVC conduit can be concealed within walls, floors, or ceilings, directly buried or embedded in concrete in buildings of any height. And I just wanted to show this is some pretty good sized conduit here. So you can see that this is probably a large application. Exposed locations. Schedule 40 PVC conduit is permitted where not subject to physical damage, and that then becomes a judgment call. And then where exposed to physical damage, there's a note, Schedule 80 PVC is identified for use in areas subject to physical damage. Ryan, did you see that? Anything in the UL White Book? Not a big deal. Not a problem.
On it, man.
In the UL, that's okay. I know I pulled it off here real quick here. In the UL White Book, and Ryan, look at the 352.10F note in the code book itself for me, or Eric, please doing that. The UL White Book specifically says that Schedule 40 PVC is not listed to be subject to physical damage. But where it is going to be subject to physical damage, Schedule 80 PVC can be used for that specific application. So I don't know if 352.10F says something specifically in the code. I'll let you guys kind of tell me what that says.
Okay.
Eric?
352.10F, exposed. PVC conduit shall be permitted for exposed work. PVC conduit used exposed in areas of physical damage shall be identified for use. And the informational note says PVC conduit type Schedule 80 is identified for areas of physical damage.
Okay, so it's actually contained in the code about that rule that's referencing and actually it's in the UL White Book. Conductors rated at a temperature higher than the listed temperature rating of PVC conduit must not operate at a temperature above the raceway listed temperature rating. Now, do me a favor, check the code language, guys, because see, the PVC actually, let me see if I have a photo here, actually has a marking that says maximum 90 degrees C wire. And I had a question asked, not that that's the scope of this class, about medium voltage cable. That medium voltage cable is rated 105 degrees. And now you're taking a 105 degree rated wire and you're putting it into PVC, which is the practice, into 90 degrees C maximum wire. Eric?
Okay, the actual code language says conductors or cables rated at a temperature higher than the listed temperature rating of PVC conduit shall be permitted to be installed in PVC conduit, provided the conductors or cables are not operated at a temperature higher than the listed temperature. And in terms of your comment about medium voltage cable, you're absolutely right. The MV105 is a 105 degree rated conductor, but we can't use it at any more than the MV90 rating because of terminations. So we're good.
Oh, so the terminations, what's the termination rating you use anyhow?
90 degrees. For medium voltage equipment, the terminations are almost always 90 degrees.
Yeah, but so when you're putting the current on that, you are having the current. Okay, so you're saying this maximum 90 degrees C becomes a moot point
That's
because
correct.
you're actually loading the conductor to the terminal rating of 75 degrees C or
Right.
or 90 degrees
Well,
C.
it's 90. So even if you
Oh,
have
it's 90
100,
because that equipment is 90 degrees C.
right, but the cable itself, if you're using the MV105, which is a 105 degree rated insulation, you can't use it at any more than 90 degrees because of terminations. So you're okay.
But now we talked to 110.3b. I mean 110.14, 110.14C1 talks about 75 degrees C.
Well, that's
so-
correct, but since we're medium voltage, we're not in 110.14 anymore. We're in 110.28 or something. I forget the number, but I'll look it up
Okay,
for
so
you.
it's different for over 600
It's
volts.
a
And I don't
different
want to
for
get
over
it, definitely don't want to
right.
get into that. All right, now you can see Eric got real excited about when I started about medium voltage stuff. He's like, yes. All right, let's go on to 352.12, uses permitted. B, PVC conduit cannot be used for the support of luminaires or other equipment. Plastic. C1, C, 352.12C. PVC conduit must not be used with substantive physical damage unless identified for such use. You see this all the time. PVC is outside. So that's a perfect example where Schedule 40 would not be permitted, but Schedule 80 is. Brian, you use a lot of PVC. You don't want to go with conduit because you're in Florida. It's sunlight resistant. Are you having problems with the PVC over time being aged by the sun? Is that an issue?
I mean, we definitely see old PVC that's been aged by the sun, but I wouldn't say it's a real problem.
Okay. All right.
Put it this way, the PVC does far better with age than metal conduit does with age here in Florida.
Okay, gotcha. That makes sense. Everything has a life cycle. All right. 352.26, number of bends. We already know about this, right? 360 degrees between pull points. Securing and supporting. We know about this. It has to be secured with, we know about the concept. You have to secure PVC within 3 feet of termination. So here's my 3 feet of termination. Here's my 3 feet of termination. And then you have to support it at intervals not exceeding the values in 352.30. And it's really 352.30b. So then I guess we'd have to go to the table and give me the table, guys. You guys see a look real quick. And when I say that, as I'm talking to the guys, and those of you at home, always make sure, put it on pause. Anytime you see, I'm asking, hey, Ryan, so read that for me. And I should have said it sooner to you. When I'm asking Ryan to read it to you, I'm asking you guys to stop it, put it on pause. Go back and look at the code book, highlight it, tab it. Is that important? I'm trying to draw you into the code book, and let's look at the language, not what the graphic says, not what I say, not what we say here in the team. I mean, I'm sure when we get done with this recording, actually, when we actually record things, the next day we realize, ooh. Like I said something about cutout boxes back in the first DVD, that it was a dome hood. Well, Don sent me a thing, and he said, no, Mike, a cutout box. And he showed me the internet picture of that and sent it to me. So go on the internet, read about a cutout box. So, even we make mistakes. We really don't want to make a mistake. We're trying so hard. But the most important thing is get to the code book, have your code book, customize it, make it the way you want to. All right, back on that table. What do we got happening on the table? Anything we need to know about?
Yeah, it depends on the size. But you know, for 1/2 inch to 1 inch, I think is most common. It's 3 foot maximum spacing of supports. And that gets violated a lot.
Hey, look at this photo right here.
Yeah.
So this is probably 1/2 inch to 1 inch, right?
I think so.
Looking, there's a little box right here. You can't really see that down here, but there's a box right here, the connector. So it's supposed to be every what?
3 feet.
3 feet.
Mm-hmm.
And then, what's the maximum I can span it?
Well, this is for 6 inch PVC, right? But even that though is only 8 feet. So you're never allowed to go 10 feet like we would for a traditional raceway.
EMT or rigid
Right.
conduit. Yes.
Well, I know we don't talk about best practices, but the reality is you're needing to strap it at a minimum every 3 feet if you want it to look good 3 weeks after you put it in, because the first time it's hot and cold,
Expands,
it
contracts.
expands, contracts. Even with expansion fittings, it still is not going to stay straight if you don't put an adequate number of straps.
Well, and maybe one of you guys knows because I don't, but the strap in that photograph is just a regular old metal one-hole strap. Is that a problem? I've heard about PVC straps that allow the pipe to shrink and get.
I want us to get in the
You wanna
code book.
table that?
Yeah, we're gonna. I want us actually. I want to have you go to it when we get into the expansion. I want to talk about what the code says about the straps when we get into expansion. So go ahead and we're
Yeah,
going
I'll
to get
just
into
table
that in a
that.
few minutes. But let's look at this photo right here. Obviously, you have to secure it and support it. I mean, this is just like right in the middle of the up. Expansion fittings. Let's go to 352.44. Expansion fittings must be provided where the change in length of a straight run between secured mounting items is determined to be a 1/4 inch or greater. Right here. This right here is no question about it. That is a straight run and it's secured. We need to allow that raceway to expand and contract. This one's a little different story. You have a 90 and then you have a 90. And because of that, it's not a straight run between secured mounting items. That allows me to get rid of it. I don't have to have, actually, we need to remove this expansion fitting here, Mike. Straight runs between 2 secured mounted elbows because the raceway is not straight because the raceway has 290. So I don't need an expansion fitting here. You guys agree with that? Double check me. And those of you streamers, make sure you those that are watching this at home.
Yeah, I don't know about that.
Why not? It says straight runs between secure mounting items. It's not a straight run.
Secure mounted items such as boxes, cabinets, elbows.
Oh,
or other conduit
okay, then
terminations.
we need to change the graphic here. Straight runs between securely mounted items. So, because we can't do it in a graphic,
Comma,
we probably have
including
a little.
elbows.
We should have a little note here. Secure mounted items include
Sure.
elbows, boxes, boom, 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 boom. So we want to have that. What the items would be. All right. So therefore, I need an expansion fitting between that when it's going to be more than a 1/4 inch change. Let's say mounted when determined to be a 1/4 inch or greater. If we look at table 352.44, it's a little bit differently. What it says is that if you have a 100-foot run at a temperature of 100 degrees Fahrenheit, it will tell you that the expansion is going to be 4 inches, right? And if I go to a 50-foot run at a 100-degree change, it's going to be 2 inches. And if I go to a 25 feet at a 100-degree change, it's going to be 1 inch. So now the question comes up is, well, let's talk about a couple of the elements. What's the percent change? Well, I think that the percent change, there's no formula here, okay? One could argue is, well, how cold could it get here? I know today we're doing a DVD recording, and I got Don in Illinois, and he's saying it's minus 17 degrees. Mike Horwath, my partner here in crime, he says that Michigan is minus, what did you say? 35 chill factor. Oh, 35 chill factors wouldn't be a factor, but still it's minus degrees. And then, of course, I'm sure up in Chicago it gets hot or anywhere else, so it could get maybe 100 degrees. So I'm thinking 100 degrees is a reasonable range. But you said, Mike, I understand you could get it could be more than 100 degrees, but I like working 100 degrees because it's a reasonable number, I think. You could go anywhere from 0 to 100 degrees, or you can go from -10 to 90, or so you pick it out. So, I mean, if you're saying, no, Mike, it can never get from the coldest to the hottest, could never then pick up with that range. Now, this is not ASHRAE going into the tables to find out what the ambient temperature is. This is a physical property. How cold could it get? And it's going to do what? It's going to then have shrinkage. How hot could it get? Then you're going to have what? Then it's going to expand. So now we have this expanding. Okay, try this again. We have this expanding and collapsing because of temperature change. So if there's a 100-degree change, right, from 0 to 100, it's going to be 4 inches. Now, when we go to put in the fitting, now I'm going to have Eric explain, okay, Mike, once we know that it can go as low as here or as high as here, 4 inches. Eric, tell us what we need to know about once we calculate that factor, what do we do? How do we put in the fitting?
Well, it depends on the temperature during the actual time that you're installing the fitting.
Hold on. Hold on. I'm just taking slow one time. You're saying, hey, I'm putting it in and it is 0 degrees. I'm putting it in and it is 100 degrees. I'm putting it in and it's 50 degrees. I'm putting it in and it's 80 degrees. You're saying, what is the temperature you're putting it in? Go ahead.
Right, because once you've decided, well, you look at the temperature, find out what actual temperature it is that day. Let's use your example of 0 to 100 degrees F.
I like
is the
that
range.
one too. Yes.
That's easy. Okay. Let's say the fitting has got 1 inch of play in it, just for the sake of discussion. Okay. Well, if you're installing the fitting on
Hold on. We can't use an example of 1 inch of play when we're having 4 inches
Oh,
of
okay.
expansion.
Well, let's use 4 inches.
Hold on, I
then.
tell you what. Let's do this. Let's go with. Let's just go with 4 inches.
4 inches.
Yeah,
Okay,
let's keep
fine.
it.
Let's say our fitting will actually move 4 inches, slide
Okay.
in and out 4 inches.
Okay, perfect.
So if you're installing it on a day that's 50 degrees, which is right in the half of your range, right in the middle, well, then you have to actually slide that expansion fitting in the mid-mark, 2 inches. And so, because you have to understand that during that temperature, that conduit is in half of its range. Now, let's just say that you install the conduit on a day that's 75 degrees. If you install the conduit on a day that's 75 degrees, it is 3/4 expanded.
Hold on. 75 degrees. I need to realize that it's 3/4 expanded. That I need to make sure I cut the raceway when I put in the fitting. Actually, I guess I would have to say, okay, this is 4 inches. I would mark it, this is 0 degrees, right?
Right.
And then I can mark this as 100
all
degrees.
All the way slid out would be 0 degrees.
So I would
all the way slid in would be 4.
I would slide it all the way out and I'd mark 0, right?
It'd be 100.
Slide all the way
0
in there
degrees.
and then I'd mark, no, all the way out would be marked 100.
No, all the way out would be 0 degrees because it's contracted.
But if I slide
The conduit contracts,
you're saying-
and so it pulls out.
that would be 100 degrees, all the way out.
All the way out to 0 degrees.
All the way out is 0 degrees.
All the way pressed in is 100 degrees.
100 degrees. And then if I took a ruler and I put little marks inside
Right.
there, and
And this is the problem, is you don't have gauges on these expansion fittings, and so you really do have to mark the conduit, and you have to do this while you're installing it.
Perfect. Brian?
I was just going to note, for those of us that are a little less technical than Eric, I just found a really great publication by Carlon on their expansion fittings.
Hold on.
has
Who would have
pictures.
thought to contact the manufacturer of
It
expansion?
has pictures.
And
for,
pictures.
For those of us that are electricians, we like pictures. It has pictures saying exactly what Eric just said. And it also says that up to 1.5 inches, you get 4 inches of travel in an expansion fitting. And from
4
2
inches.
inches, 4 inches, and from 2 inches to 6 inches, we get 8 inches of expansion in the fitting.
Okay, Victor.
I was going to say that the 100 degrees that we're talking about, that would be good if we went back to your graphic before where we had the things on the side of the building. But if you go up on the roof, 150 is not unreasonable.
Yeah.
Oh, I see what you're saying. I'm just thinking about temperature. But where are you placing this?
Yeah.
You're placing this on the roof, so maybe the thing is, my maximum temperature, if I thought it was 100, maybe I need to realize how far off the roof am I going. I might want to use that adder on there because we have that roof adder on there.
Yeah.
We okay with that? All right, I like that. Here's a photo of an expansion fitting. So again, Eric, you brought out, well, let's get more information before we do something like that. All right, before I move on to, here's an example. 100-foot run. There's a calculation that I have in the textbook that talks about that. Now, this shows an example here of it changes from 80 degrees Fahrenheit, ambient temperature from 80 degrees Fahrenheit to 150. Is that what that is? Oh, okay. This is having to do with the temperature can go as low to 10, I don't know why I picked that number, to as high as 150. But if I'm setting it at 80 degrees, but it can go as high as 50, then I got to be sure to recognize that's going to expand 2.8 inches. If I'm setting it at 80 degrees, but it can get as cold as 10 degrees, which is going to be minus 7 degrees, well, then it contract as low as 2.8 inches. So this helps you say, okay, I'm setting it this, how far can it go up, how far can it go down, and you can have a formula in there. Brian?
And that's a really subtle point, but if you look at Mike's graphic there, in that particular instance, you would have needed 2 expansion fittings. He's got them both tight in the middle of the run, which is exactly how they need to be installed. You don't just put them in every 100 feet. And again, that's information you'll find on the manufacturer's installation instructions.
Because you're an expert now.
Exactly.
Because you just looked it up and just found out.
I just told you I have a picture in front of me, and Mike's picture is perfect.
Okay, now, you're telling me if this is like up to what size it'll expand how much?
Up to 1.5 inches, it'll expand 4 inches.
Hold on.
4 inches.
Does that mean +2, -2?
4 inches total.
Okay, so it means +2, -2.
Correct. Sure.
Okay, the answer is yes. Okay, Ryan?
We were going to talk about the support hardware.
Yeah, you're going to go there? Good, go right now. It's 352.30.
Right.
Let's talk about
So,
the securing of it.
So do they have to be like the gray PVC?
Let's read the
tools?
rule.
Oh, I'm
Why
sorry.
don't you read the rule of 352.30.
Yeah, so a PVC conduit must be installed as a complete system as provided in 300.18 and must be fastened so that movement from thermal expansion or contraction is permitted.
Right. So the code says you need to allow that raceway to, I won't say breathe, but I mean to be able to move back and forth. So the code doesn't say you have to use specific fitting, but I got a feeling Carlon and other PVC manufacturers make straps specifically for their products that designs it. Brian, is that what you use all the time, or do you do something different?
That's the expert.
I cannot lie.
I know, that's why I asked you.
We don't like the Carlon
Why?
PVC 2-hole straps. They don't have the mechanical strength that a 2-hole metal strap has. And we have found that the 2-hole metal strap allows the pipe to move adequately. You can't use a 1-hole strap because it clips onto the pipe really tight and it doesn't let it move. But I'm not saying that Carlon is a bad product, just we haven't had a great experience with it.
All right, Victor, I thought, didn't we have a conversation, or there was something, maybe you and I had a conversation about where if you put raceways on top of the roof, that it expands and contracts, and people have actually, electricians, put the Romex, right? Just nail that baby. This mechanical stuff, make that solid, not recognizing the physics that are taking place inside here. Imagine taking conduit, putting it on a roof and putting it on sleepers, which is like, some wood, and then it expands and contracts and it doesn't move. What happens? It pulls it off the roof.
Yep.
It damages the roof. And you can have some long runs of conduit on top of a roof, so you have to make sure allow it to it. But that's going to be a real problem because you'd have to support that like almost every X feet, quite a bit of straps inside here, so just be aware. Let's move on. 352.46 bushings. I didn't know if you needed a bushing on PVC, if you don't need a PVC, I run around, and I still don't know, okay? But if you look at the language at 352.46, and if you look at 300.4G, it looks like it's reasonable to say that probably when the PVC, the edge itself, doesn't have a smooth, rounded surface. So if it's 4 gauge and larger, you need to provide some kind of protection of this conductors. you can put a bell end, right? That'd be one way to do it. Right here is a bell end. But if you went into a race or what's that called, a box fitting?
Box adapter.
A box adapter, you can put that on there. Or if you probably I could put a box. Well, I don't have to do that. But you could put you could terminate into an enclosure, but you're still going to have the bushing. So 4 gauge and larger, you're going to have to provide some kind of protection of the conductors. Equipment grounding conductor. It's interesting when you read. Everybody thinks that when you run PVC, you need to bring that green wire inside the PVC. Well, yes, you have to always bring an equipment grounding conductor PVC when you're going to use it. You know, well, what do you mean when you're going to use it? Well, you don't always need an equipment grounding conductor. But when you need an equipment grounding conductor, it needs to be in the raceway. So when do you not need an equipment grounding conductor? Well, you don't need an equipment grounding conductor at service equipment, because the meter enclosure is bonded to the neutral enclosure automatically. That's the way it's done. Your service disconnect 250.24c tells us that we have to bond that neutral conductor from the service. We have to bond that to the enclosure, which means now the service disconnecting means the main means of cutoff is bonded to the grounded neutral conductor to clear fault. If I put PVC between here, now, Brian, you would say you would run PVC between here and put a box adapter. Is that right?
Correct.
Get with Mike. I'd like to change this graphic. And because that's where it really looks like a great idea.
It's outstanding.
Yeah, and if you get a chance to get me a photo of that,
Sure.
a nice, pretty photo, that would even be better if we add that in there. Okay, but I don't bring an equipment grounding conductor in here, because if I did, I'd have to connect it to the neutral. And then on the other end, I have to connect it to the neutral. Well, if you connect it to the neutral at both ends, then you have what? A parallel conductor. Now you got to go to 310, that 10/8 rules on paralleling. It can't be less than 1 off. They have to be the same length, the same size, the same material, terminate the same manner. They're not the same size because they serve different purposes. And so now you can talk about objectionable current, 250.6, that you can't have current traveling on the equipment grounding conductor. Well, so that's a code violation. You don't always bring an equipment grounding conductor in PVC. Okay, Eric, you had a comment you want to make about this particular graphic.
Yeah, we're in Article 352, and this is talking about PVC, and we're talking about expansion joints, but it's also good to note that whether you're running aluminum conduit or steel conduit, you still have to be mindful of this. In fact, in Section 300.7b, the section is entitled Expansion Fittings, and it says raceways shall be provided with expansion fittings where necessary to compensate for thermal expansion and contraction. In an informational note underneath 300.7b, it says that in order to do this, if you're dealing with a steel raceway, you can use this same PVC table, but multiply the results by 0.2.
Hold on. So you're saying, if I look at this graphic here, if I take the 4 inches at 100 feet and it's 20% for steel, then if I had it, here's 1 inch right here, if it was 0.8 of an inch, the expansion characteristic would be 0.8 of an inch per 100 feet.
Correct.
Okay?
And then also in the next paragraph, it's quite a long informational note, but the second paragraph talks about aluminum and says that you can use this PVC number and multiply it by 0.4.
So then it would be not 4 inches, but it would be 0.44 inches, which would be 1.6 inches would be the expansion characteristics.
Right.
Okay? I think we're done with rigid non-metallic conduit.